Exact ratios, exercise 6.6. We did touch on this in year 10, but we'll just have a look at it again. You will have two diagrams on your formula sheet. One of them is a right angle triangle with side lengths 1 and 1. It's an isosceles right angle triangle. So if this side length is 1 and that one's 1, we've got an isosceles triangle with angles of 45 degrees. And the hypotenuse, length of the hypotenuse is what? Hypotenuse here. The hypotenuse will be the square root of 1 squared plus 1 squared, using Pythagoras' theorem, which is root 2. So therefore, we can look at the sine of 45 degrees. Remember, sine is opposite over adjacent, which is 1 on root 2. The cos of 45 degrees is adjacent over hypotenuse, which is 1 on root 2. Now, this makes sense that they are both 1 on root 2, because they're complementary angles. Sine 45 equals cos 45 because 45 and 45 adds up to 90. And the tan of 45 degrees, actually I'll just do it down here, and the tan of 45 degrees equals opposite over adjacent, which is 1 over 1, which is 1. Now the way that you can do these on your calculator, you may remember from last year, is if you can't remember the rule, you do on your calc, you do sine of 45 squared. So you do sine 45, you press equals, and then you square it, and you get a half. So therefore, sine 40, because you squared it, you need to go back and square root it in your head. And the square root of 1 is 1, and the square root of 2 is the square root of 2. On your calculator as well, you could do the cos of 45 square, and then square it, and you will get, so when you do cos 45, you get like 0.707 whatever. You press squared, x squared, you'll get a half, so you know you have to go back and square root it. Tan of 45, you don't need to square it, because when you do tan of 45 on your calculator, you just get 1. The only time you would go and square on your calculator is if you get a value that's not something like a half, or something like that, or 1. Okay? Now, that's the exact values for angles of 45 degrees. Now, we use an we use an equilateral triangle, but only half of it for our other angles. So if we have an equilateral triangle with side length 2, 2, 2, and these angles will all be 60, however, if I put a line, an axis of symmetry down the middle of this triangle, instead of having 60 at the top, wouldn't I have 30 degrees and 30 degrees? Now, I'm going to draw another diagram in a minute. I said equilateral triangle, side lengths 2, 2, 2, angles 60, 60, 60 degrees up there, but if I put an axis of symmetry down the middle, the whole length there is 2, but what would be, and this would be a right angle, what would this length and this length at the base be? They would both be 1. So what I'm going to do now instead is just draw one of the triangles with the right angle triangle. I've got 60 degrees, 30 degrees. I know I've got 2 there and 1 here. I work out my remaining side. I'll just call it x. And x is a shorter side using Pythagoras. I could do x squared is 2 squared minus 1 squared. Or couldn't I just do x is the square root of 2 squared minus 1 squared, so it's the square root of 3. So this side here is the square root of 3. So now I can do my ratios for sine and cos of 30 and 60 degrees, exact ratios. So let's start with, I like to do sine 30 first. So sine of 30 degrees, sine of 30. Opposite over hypotenuse is a half. Now, if you do that on your calculator, you'll get sine 30 and it'll say 0.5. Well, you don't need to square that one, all right? Cos of 30 degrees, looking at cos of 30, adjacent over hypotenuse, that's root 3 on 2. Now, if you do cos 30 on your calculator, you don't get a nice answer. You get 0.866 something, whatever. So you square it. And you will get 0.75 or 3/4. Square root those, you get square root of 3 over square root of 4. which is square root of 3 over 2. Tan of 30 degrees is tan of 30, opposite over adjacent, 1 on root 3. Now, if you do tan of 30 on your calculator, you get 0.3 something, I think. I can't remember. No, you don't. 0.17, I can't remember what you get. 57, whatever. It's not nice. You square it and you get 0.3 recurring. Now, you know that that's 1/3. So if you've squared that, go back and square root it. Square root of 1 is 1, square root of 3 is root 3. Now, from what we did yesterday, which was complementary ratios, see, I just make sure I remember sine 30 is a half. So I say sine 30 is a half, that's the nice one. Doesn't cos of, sorry, I'll just do sine of 60 as well. Sorry. Sine of 60, from what we learned yesterday, doesn't sine 60 equal cos 30 because they're complementary? But let's have a look. Sine of 60 is opposite over a hypotenuse, so it's root 3 on 2. Notice that sine of 60 equals cos 30, but we know that from yesterday. 60 and 30 adds up to 90. They're complementary. Cos of 60, well, that should be the same as sine 30. So let's have a look at the diagram. Cos of 60 is adjacent over a hypotenuse. It's a half. But we know that sine 30 should equal cos 60. And we know that cos 30 equals sine 60. So you only need to know one of them. So sine 30 is the nice one, a half. The other one's root 3 on 2. They're both over 2. So sine 30 is the same as cos 60. They're a half. Cos 30 is the third one, root 3 on 2. It's the same as sine 60. And if tan 30 is 1 on root 3, tan of 60, anyone? Is? Yeah, tan of 60 is opposite over adjacent. It's root 3 over 1, which is just root 3. So you can look at the tan ones. The smaller tan, tan 30, is 1 on root 3, but the bigger tan, tan 60, is root 3. Okay, so sine of 60, if you didn't know what that was, you've got your formula sheet or your calculator. If you square that, whatever you get, 0.877, if you square it, you get 0.75, which is 3/4. Go back and square root it. Cos of 60, if you do that on your calculator, you'll get a half. No need to square root that. Okay, and tan of 60 on your calculator, if you do that, I think you get 1.732 something. So you would square it and you get 3. So then you know it's root 3. Okay? Just some examples. Now, remember that sec is the reciprocal ratio of what? Cos. So this is like 2 times 1 over cos of 60 degrees. Are we okay with that? 2 sec 60 means 2 times sec 60, but sec is 1 over cos. All right, it's the reciprocal of cos. So that is 2 times 1 over. Now, cos 60 is the same as sine 30. What's sine 30? A half. So it's 2 times 1 divided by a half. So it's 2 times, now 1 divided by a half is 2. So it's 2 times 2, which is 4. Now the next one. Sine 45 cos 30 plus cos 45 sine 30. Sine 45 is 1 on root 2. Cos 30, well, sine 30 is the nice one. It's a half. That one's root 3 on 2. Plus cos 45 is 1 on root 2. Sine 30 is the nice one, which is a half. So this is root 3. What are the denominators of both of them? 2 root 2, they've both got denominator 2 root 2, because they're the same. Root 3 plus what? Because this is, look, it's root 3 over 2 root 2 plus 1 over 2 root 2. Let's just write it as one single fraction, because the denominators are the same. Root 3 plus 1 over 2 root 2. Now I need to write it with a rationalised denominator. So what do I multiply by? 2 root 2 or just root 2? Root 2 over root 2, which is, now I'm going to put brackets here. So it's root 2 times root 3 is root 6 plus root 2 times 1 is root 2 over 2 root 2 times root 2 is 2 times 2, which is 4. Now, you must write it with a rationalised denominator. What's that? 1 plus 10 of 60, 1 plus root 3 over 1 minus 1 times root 3. So isn't that just 1 plus root 3 over 1 minus root 3? Now, the denominator is not rationalised. Let's rationalise. How do we rationalise this? Multiplying by 1 plus root 3 over 1 plus root 3, which is, isn't this 1 plus root 3 squared? So isn't that 1 plus 2 root 3 plus 3 over, that is 1 plus root 3 all squared. That is 1 plus root 3 squared over 1 minus root 3, 1 plus root 3. We've got a perfect square over the difference of two squares. So it's 1 plus 2 root 3 plus root 3 squared is 3 over what? 1 minus 3. Now, 1 plus 3 is 4 plus 2 root 3 over negative 2. And now I can divide, this is 4 over negative 2 plus 2 root 3 over negative 2. I divide everything by negative 2. What do I get? Negative 2 minus root 3. Because it's 4 over negative 2 plus 2 root 3 over negative 2. So it's negative 2 minus root 3. Now, when I want to write cosec 60 squared, they put the squared here. They don't put the brackets there and write squared. So this is cosec 60 squared. So that means 5 times the cosec of 60 squared. That's what it means. Now, cosec is the reciprocal ratio for what? Sine. So it's 5 times 1 over sine 60 squared. Now, what does sine 60 equal? Now, instead of going 1 divided by root 3 on 2, now this is what I want to write on the side. Sine 60, sorry, actually, I shouldn't have, yeah, that just shows you that it's a reciprocal ratio. Sine 60 is root 3 on 2. What's better to do is actually write cosec 60 is 2 on root 3. That's actually easier. I don't want to go 1 divided by root 3 on 2. I'd rather you write, the reason I'm writing it here is that you know that it's the reciprocal ratio. So I'm just going to go 5 times, now what's cosec 60? 2 on root 3. So it's 2 over root 3 squared, instead of going 1 divided by root 3 on 2. Do you know what I'm saying? So really later you don't have to really write this. I reckon you just need to write the bit on the side and jump straight from there to there. I wouldn't write it. I would just do it on the side. Sine 60 is root 3 on 2, cosec 60 is 2 on root 3. It's the reciprocal. 1 over a fraction is the flip of the fraction. So what's that equal to? 5 times 4 is 20 over 3. Root 3 squared is 3. So you don't need this. I'm going to leave that out from now on. And the last one, 2 minus tan 60. That's 2 minus root 3 over, now sec is the reciprocal of cos, so over the side cos of 45 is 1 on root 2. So what's the sec of 45? Root 2 on 1, or just root 2. So what's this? Root 2 squared, isn't it? Because it's sec squared 45. So that's 2 minus root 3 over 2.